Betelgeuse's spectacular journey. A cosmic perspective. Set yourself up for an interstellar stunner. A group of researchers has determined that Betelgeuse, the mesmerizing red supergiant adorning Orion's shoulder, has already detonated. That's right, you heard that correctly, this isn't a joke. Within the next 10 years or so, its brilliant repercussions will illuminate the night sky. But how did scientists arrive at this conclusion? Should we be concerned? Might the James Webb Space Telescope capture the remnants of Betelgeuse? Today, we're diving deep into all the latest details. Betelgeuse is possibly one of the most notable stars in the night sky, particularly in the northern hemisphere during winter. This red supergiant is among the few stars that shine brightly enough for us to see. In fact, its rosy orange hue makes Betelgeuse the 10th most brilliant star in the night sky. However, as you may know, it has always been known to vary in brightness. Part of the justification for this is that Betelgeuse is by no means your average star. Due to its monstrous size, if we were somehow capable of replacing Betelgeuse with our own little sun, it would extend all the way to the asteroid belt and have a mass multiple times that of the sun. It might come as a shock, but Betelgeuse is relatively young for a star, with an age estimated to be around 8 to 10 million years. In comparison, our own sun is much older, with an expected age of about 4.6 billion years. This is because supergiant stars like Betelgeuse consume their atomic fuel rapidly and go supernova relatively quickly on geological timescales. This also means they evolve quickly, and Betelgeuse may indeed have done so right before humanity's eyes. To understand how researchers came to the conclusion that Betelgeuse has already detonated, it's essential to delve into the context. The story begins around the 2nd century BC, when Chinese cosmologists made a critical observation that Betelgeuse exhibited a particular yellow tint. Fast forward to the mid-2nd century AD, and the Greek stargazer Hipparchus described it as orangish or rosy, similar to how it appears today. Medieval eyewitnesses in the Middle East saw a similar hue. The inquiry emerges about how colors were named or perceived in the past. However, it's plausible that Betelgeuse underwent a color change over a few centuries. It is conceivable that Chinese cosmologists observed Betelgeuse during its yellow supergiant stage, and over the centuries it progressed into the red supergiant stage. Given our tendency as night sky watchers, one must consider how many individuals across the globe could see the star and observe the change, yet left no records. After all, changes to a star like this presumably came with a wide range of dimming and brightening events that went unrecorded. Imagine them looking up at the night sky and saying, "Hey, didn't that star used to be more brilliant?" And that is precisely what has been happening recently. Betelgeuse is a variable star, but it appears to be adjusting to some cyclic behavior. Beginning in December 2019, Betelgeuse's brightness strangely plunged dramatically, which was observable to the naked eye for those accustomed to looking at the star. It was not its typical self until mid-2020. Over time, it recovered, and one hypothesis was that some of these cycles had harmonized, making for an especially deep plunge in brightness. Observations made by the Hubble Space Telescope showed something rather peculiar. It appeared that Betelgeuse had expelled a massive amount of scorching material into space, forming a tremendous dust cloud. This dust cloud, in turn, obscured a significant portion of the star's light when viewed from our perspective. The change was shocking. Betelgeuse, once counted among the 10 brightest stars in the night sky, fell to lower than the 20th position. Fortunately, Betelgeuse began to show signs of improvement. However, its unusual behavior did not stop there. In fact, it has recently exhibited a significant increase in brightness, outperforming its ordinary radiance by a staggering 50%. This extraordinary circumstance is quite disruptive for a star known for its variability. The dimming events could be attributed to dust or matching cycles, or perhaps the star generated tremendous sunspots. A critical increase in brightness, however, is something else entirely. Despite the possibility that it may be connected to the past event when Betelgeuse expelled material in late 2019, it could have caused a significant disturbance in the star's plasma flow. The current behavior we observe could be considered a delayed repercussion of that discharge. What lies behind this exceptional behavior, surpassing the star's normal fluctuations? One moderate speculation that has gained traction is that Betelgeuse is approaching the supernova stage. While estimates still suggest that the star is around 100,000 years away from a supernova event, we will provide evidence to scrutinize this thought and demonstrate that it has already occurred. So, what is the proof? According to a monumental late scientific paper by Hideyuki and Associates of Tohoku University in Japan, Betelgeuse has already undergone a supernova explosion, and we might be witnessing the repercussions of this grand event within the next 10 years or a couple of decades. Yes, that's right. As astonishing as it sounds, the last notable supernova in our galaxy was the Kepler supernova, which occurred as far back as the 1600s. Through a thorough assessment of Betelgeuse's variability patterns, specialists have identified 4 distinct periodic changes occurring at time intervals of 2,200, 420, 230, and 85 days. While the origin of the longest period remains obscure, it is estimated to be the crucial period, with the shorter stretches possibly serving as hints. Specialists propose a model suggesting that Betelgeuse is in a late phase of carbon burning, indicating that it may be on the verge of a tremendous blast, positioning it as a notable contender for the next expected supernova event within our Milky Way galaxy. When disentangling the mystery surrounding Betelgeuse, there is a bit of a riddle. You see, some conflicting observations exist regarding the launch of materials and the star's ensuing recovery. The overall consensus leans towards a mass discharge event, something not entirely incomprehensible for different types of stars, albeit on a more modest scale compared to our own Sunday. Yet here's the twist. Supernovae are a real phenomenon too. We actually witnessed one in a satellite galaxy of the Milky Way back in 1987. While it's conceivable that our estimates for Betelgeuse's supernova timing could be off, don't go planning a trip around it just yet. The tricky part is that Betelgeuse has currently slipped behind the sun and will not be visible in the night sky until at least August, leaving us in the dark about what this cryptic star is up to right now. What we do know, however, is that it's deviating from its normal patterns by lighting up. Here's something intriguing. Betelgeuse's enormous size and relative proximity, roughly 650 light-years away, allow us to determine a plate. While observing it, most stars are just too far away, appearing as simple points of light. Yet with Betelgeuse, we have a unique opportunity to capture direct variations in its light output through photography. So we not only have a star that could possibly go supernova, but also plenty of information to gather, including images, even if they might be a bit hazy.
Let's imagine the scenario where Betelgeuse has indeed gone supernova. How might it look? Priorities straight. It will be a genuine spectacle, but don't worry, it's completely safe for us here on Earth. Betelgeuse is far enough away that its explosion won't harm our planet. However, it will not be the most brilliant object overhead. The moon will still dominate it by a wide margin, and we should not disregard the sun. The supernova would create its own shadows around nighttime and remain visible during the daytime for about a year. Here's the interesting part. The supernova would be noticeable at night for quite some time, continuously fading away. There may be a brief period where it recovers some of its previous brightness. However, ultimately, it will continue to fade until the recognizable shoulder star in the constellation Orion vanishes entirely. While this supernova won't pose any threat to us, it could create some confusion. After all, some creatures depend on starlight for navigation, and with an extra brilliant light overhead creating shadows, it could throw them off their game a bit. But that's not all. Cosmology itself would face challenges. Observing the night sky from Earth when the moon is shining brightly can be tricky, and an exceptionally brilliant supernova would complicate matters further. Many telescopes would probably be more keen on capturing the supernova's grandeur than anything else, even if it means changing their observations. Plus, there would be warning signs before the apparent blast, such as detecting neutrinos and gravitational waves from the star. However, here's the central question. If Betelgeuse has already gone supernova, might we catch the remnants? For that, we need to wait for the James Webb Space Telescope to detect the supernova's remains. So, how long might it take for Betelgeuse to go supernova? We're not completely certain, but it could happen as soon as next week, next year, or in 100,000 years. In astronomical terms, that's essentially equivalent to right now. After all, forgetting that the light we see from the star is actually very old. If it exploded, we'd only have to wait until the event reaches us. As we ponder the possibilities of Betelgeuse's journey through time, the idea of supernovae transcends its immediate implications. These cosmic explosions serve as invaluable tools for understanding stellar evolution. They contribute to the enrichment of the universe with heavy elements and help us understand the life cycle of massive stars. Investigating Betelgeuse's fluctuations allows astronomers to refine models of stellar evolution and the transition to supernovae. As we continue to explore the cosmic significance of Betelgeuse, it's essential to highlight the profound implications a supernova would have on both local and galactic scales. When a star like Betelgeuse reaches the end of its life cycle and undergoes a supernova explosion, it doesn't just end its existence. It plays a crucial role in the cosmic ecosystem. The remnants of such an explosion contribute to the interstellar medium, enriching it with heavy elements such as carbon, oxygen, and iron. These elements are vital for the formation of new stars and planets. Thus, the life cycle of massive stars like Betelgeuse directly impacts the chemical composition of the universe. In a way, each supernova acts as a cosmic recycling process, facilitating the birth of new celestial bodies. Moreover, studying Betelgeuse provides astronomers with an opportunity to examine the behavior of massive stars under extreme conditions. By analyzing its light curves, researchers can glean information about the star's internal processes, including temperature variations and the dynamics of its outer layers. Understanding these factors can lead to improved models of stellar life cycles and help scientists predict how similar stars will behave as they near their explosive ends. The potential for Betelgeuse to go supernova also raises intriguing questions about the broader implications for Earth. While its distance ensures that it poses no direct threat, the cosmic radiation released during such an event could still have effects on our planet's atmosphere. Increased cosmic rays might influence cloud formation and climate patterns, albeit on a minor scale. This connection illustrates how interconnected celestial phenomena are, reminding us that events in the universe can reverberate across vast distances and time scales. In addition to scientific inquiries, Betelgeuse's story captivates the public imagination, sparking interest in astronomy and space science. The anticipation surrounding its potential supernova serves as an educational opportunity, encouraging more people to engage with the sciences. Such public interest can drive funding and support for further astronomical research, ultimately benefiting the field as a whole. As we await further observations from advanced telescopes, including the James Webb Space Telescope, it is also worth considering the technological advancements that make such studies possible. The development of highly sensitive instruments allows astronomers to detect even the faintest light signatures from distant stars. These innovations enhance our understanding of stellar phenomena and expand the frontiers of astrophysics. In the coming years, as Betelgeuse continues to exhibit unusual behaviors, it will serve as a living laboratory for astronomers. Each observation may provide new insights into the processes governing massive stars and the eventual transition to supernovae. With each passing moment, we are reminded that the universe is a dynamic and ever-evolving landscape filled with mysteries waiting to be uncovered. The quest to understand Betelgeuse reflects humanity's broader curiosity about the cosmos. As we delve deeper into the intricacies of stellar life cycles, we also confront questions about our place in the universe. What does it mean for us, living on a small planet orbiting an average star, to witness the fleeting moments of massive stars like Betelgeuse as they blaze brightly before their dramatic endings? This contemplation invites both humility and wonder, reminding us of the beauty and complexity inherent in the universe we inhabit. As we delve into the enigma of Betelgeuse, it's fascinating to consider how cultural narratives surrounding stars have evolved. Throughout history, this iconic star has inspired myths and stories across different civilizations. Its prominence in the constellation Orion has led to various interpretations in folklore and astrology. Ancient cultures often looked to the night sky for guidance, attributing celestial events to divine messages. In modern times, Betelgeuse's potential supernova serves as a powerful symbol of change and transformation. It embodies the cyclical nature of life and death in the universe, reminding us that even the most magnificent entities eventually face their demise. This aspect resonates deeply with human experiences, prompting reflections on mortality and legacy. Furthermore, the anticipation of observing a supernova can also enhance collaborative efforts in the scientific community. Researchers worldwide may unite to track Betelgeuse's behavior, sharing data and insights in real time. This collaboration fosters a sense of global citizenship in science, as astronomers work together to decode the secrets of the cosmos. Ultimately, the study of Betelgeuse not only enriches our scientific understanding but also deepens our appreciation for the interconnectedness of life, the universe, and everything within it.